Hey, so let's try in problem 1 of homework 14. And let's see how it goes. A designer wants to design a mass spring damper system to have the time response active T shown in the figure below, where x of 0 is equal to 1, x prime of 0 is equal to -1, and there is no external force acting on the system. Suppose the mass of blocks is 2 kg and the spring constant is 74. Find the value of the damping constant C that should be used. And they give us this, which is our x of pi of 3, and our t is this one right here. So I'm going to make the assumption that the damping is proportional to the derivative of the position. So applying Newton's second law in differential form, m times the double derivative of position with respect to time is equal to negative kx minus c times x dot. We can add, and we have no forcing function here. Now we can write it in standard form and substitute m and k. So let's do that. 2x double dot minus 74x. Now that becomes a plus if I'm writing it on the left-hand side of the equal sign, plus cx dot equals 0. Now I can apply the Laplace on both sides, and I get 2 times s squared big X of s minus s times small x of 0 minus x prime of 0 here. Then we have plus, and I'll do the c first, times s times big X of s minus x of 0. And then the last term is going to be plus 74 times big X of s. Now let's distribute this 2 here. After we put in the initial conditions. So initial condition for this one is x of 0 is 1 and x prime of 0 is -1. This is -1. And so this is 1. So once we do this, we distribute that 2, we get 2s squared xs minus 2s minus 2 plus csxs minus c plus 74 big X of s. All of that is equal to 0. Remember, this is also equal to 0 because if we take the Laplace of the right-hand side, the Laplace of 0 is still 0. Then we're going to group together all of these terms because they have an x of s in common. So we have 2s squared plus cs plus 74 times big X of s minus 2s minus 2 minus c. All of those should be equal to 0. So now we can write everything as x of s is equal to, if we bring these to the right-hand side, they all become positive. And now we can write here 2s squared plus cs plus 74. We can now factor these. We can write 2 times s plus 1 here plus c. And here I can take out a 2 and say s squared plus c over 2s. Complete the square. That's going to be c squared plus 16 minus c squared over 16, sorry. We factored out a 2, so this is going to be 37. Now that we have this, what are we going to do? Well, let me make some more space. Right here, we're going to have 2 times s plus 1 plus c. 2 times, we can group this as c over 2 squared. Then remember to distribute the 2, and we get plus 74 minus c squared over 8. So now that we have this, I would just put this in MATLAB and get the inverse Laplace. Laplace inverse. And then solve for c. by inputting in this, which we have to input to the time response. So let's go over to MATLAB for part B. See you there.